Hello, my name is Mihaela Gidersa, and I welcome you to the presentation BFF versus GraphQL, a critical perspective. A little bit about myself. I'm a software developer at Centric Romania, and besides my deep interest in software and technology in general, I like to prepare presentations and trainings for call events like this one today. So before starting, I want to thank you to the organizers for having me. When I'm not speaking or coding whatsoever, I like to dance, to sing, read, travel, just your typical developer. Today, I want to invite you to join me in a talk about a subject that's been very, let's say, annoying to me in the last 1 year and a half. And I'm continuously searching for better ways to improve my approach. And as you already noticed in the agenda, I want to discuss concepts and approaches, and most of them are from my experience or from some projects that I had near me. But I'm extremely interested also in your experiences. I really think that we can adapt to this presentation and do a two-way knowledge sharing. So let's just get started. Before digging into the concepts of today, I want to tell you that before maybe having a stronger focus on the front-end area, I did some years of full-stack development. So I will take the liberty to talk today about both sides of the story. Usually working in a distributed team can be frustrated unless, let's say, you are also working on the backend and frontend as you are doing full-stack. Because there are a lot of discussions about the data used, performance, inconsistencies that might appear. So we like it or not, this is the reality. And sometimes we have situations where front-end developers don't understand the perspective of the back-end developers, and they just think about why they can just provide all the data that they need and why isn't the payload exactly how they need it, and what are they doing all day. And at the same time, also the back-end developers have thoughts about, okay, why is not the front end just saying from the start what it needs and they change all the time, and what else they do besides changing stuff in front end of and requesting for specific data. And having this context and looking a bit in time, it's understandable because the feeling was that always the backend developers have done the more serious and smart programming. They were thinking about meaningful issues such as testability, maintainability, API design, state management, while the front-end colleagues just played with some pixels and just made things look pretty. Well, in the last years, JavaScript has absolutely exploded. So a lot of the responsibility went from the backend part to the front-end part. Or it is a shared responsibility, if we can say it like this. In the beginning, we had to deal with some very specific pillars in the web development, such as HTML, CSS, JavaScript, some preprocessor language. Well, now everything got way more complex. We now think about almost the same issues as in the backend. The separation is not longer valid, or at least not so big, let's say, because the issues that we just mentioned 1 minute ago about testability and even API design or state management, they were being as perceived as backend matters. Well, now are the daily debate the daily debate and work of front-end developers also. So today we are talking about the application, as I was saying, about approaches on some areas on the collaboration part. We are talking about the development team, but specifically we talk about workflow and responsibilities in distributed teams. When we talk about collaboration, and more when we talk about the data that we have to take from the server to the front end, to the client, the question that arises is, maybe are our clients managing too much? And when this actually does, front-end developers began to have a very frustrated perspective on things, and they have the feeling that they can't manage the code base anymore. Also, in the same times, the need for refactoring appears, and a lot of technical depth is being gathered. So yeah, the result is that neither clients or project managers or whoever is using the result of development is not satisfied because there are problems with the performance and with approaches and all things like that. So in order to make everyone happy and find a very quick way to do things, most of the times we go to these two approaches: create a new endpoint, or just add some more data to the endpoint that we are already using. Well, in this case, if we're talking about a very small case that does not grow in complexity, it can be something harmful. Let's say that we will just have 2 calls over the network instead of just one for a certain action. So it's not such a big deal. We can use this, especially when the application, maybe it's a small application that has very straightforward flows. But what happens when this is being done regularly and the application grows in complexity and the code base also grows? Well, we will end up with something that is called chattiness. And chattiness is not close at all to anything that comes to performance or something related. Because this kind of mindset usually ends up with a lot of business complexity. And we have to do a lot of adapter operation in the clients because, yeah, we are just trying to satisfy all needs and see which endpoint goes where. And yeah, I would know about this because I've been here. I had situations like this working with very specific endpoints, and there are a lot of issues, especially on the front end code base, because yeah, it's bringing also issues in terms of complexity, performance, but also team organization. So it's not the best approach if the project is very complex. On the other side, we were talking about adding more data to the endpoint that we are already calling. So yeah, let's say that you're actually in a very good relation with the backend developers, and you can just discuss and be like, okay, it's a good communication in this part, and you can say like, okay, I just need some 2 more properties in the payload, and they just are open and try to help. But if we repeat this process over and over again, as in the case that we had before, it becomes a problem because the endpoint is starting to return something that is called fat payloads. And we just wake up one day trying to just find some very specific properties in a very big payload or in a very big JSON file, trying to find exactly what we need. Not to mention also the fact that you have to bring all that data over the network. So it can be a very good option when it comes to performance. Yeah, some might say that maybe a fat payload is a better option than doing a lot of calls, so the chattiness, but it's not a fair trade. So I think since there are other options to consider, we can extend the discussion from here. So the result, again, it's either a one-size-fits-all API, which is something that might look like REST, might seem that it's REST, but it's not a REST API. And yeah, we've worked with endpoint APIs for so long, and it works so nice when it comes to just providing straightforward and very clear data to the client. But while development in the client area went crazy, as we were talking before, we had to fulfill a lot of needs of the users, and the complexity has grown. And alongside with this, also the requests that we are making to the backend have increased when it comes to complexity, when it comes to the way we want data. So in this way, we just end up with a lot of cases, And yeah, we have to satisfy different browsers, we have to satisfy different devices, so everything is way more complex. And without the knowledge to actually do a proper REST API implementation, we end up with this sort of one-size-fits-all APIs. And this kind of APIs are messy and hard to maintain, and usually, as I was saying, they are making us blame REST, but it's not about the REST approach. It's about the architecture and the fact that we are using an approach when designing the API that is not suitable for the cases that we are trying to work with. The other issue is related to absorbing complexity. So let's say that, okay, we thought about switching to a microservices architecture and let go of the monolith. And of course, time showed that this approach has a lot of benefits. And yeah, there is also in this part also one thing that we have to be very careful, because it might bring a lot of trouble to the front-end developers. Because with this approach, the client has to consume data from several different sources, shaping it to fit the requirements. And in this case, yeah, it seems like the responsibility for that complexity might go on the front-end side, so on the client side of the application. And this is somehow invalidated one of the important attributes of APIs, which is actually absorbing that complexity. So we have to be also very careful about how are we working with our APIs. So at this moment, it feels natural to feel a bit stuck because we are driven by some constraints we hardly have control over. But how about we change a bit the perspective and look at the advantages that this challenge is bringing? And maybe changing this context might cause that the front-end developers, since they are closest to the users, can actually have a more realistic approach on what the user needs. So would it sound that crazy for front-end developers to actually build some own servers that they can maintain and work with? And in this way, we kind of go to the first topic of the discussion that we have today, the backend for front-end pattern. So basically, to give you a bit of context, this appeared the first or the most popular, let's say, or the first popular approach of this was at Netflix when they announced somewhere in 2012 that they are doing a complete redesign. And yeah, they were talking about an approach that they were trying to use in order to get rid of the limitations of that one-size-fits-all API approach. Basically, they saw that they had a lot of complexity to deal with when it comes to one, to deal with data, yeah, and the shape of the data, and the second, because they had a lot of devices to actually respond to. So this means when you have hundreds of devices to respond to, this means fallbacks for each and every single one of them. And this makes everything very specific. So you cannot really build something that is very generic, unless you have a lot of workarounds in there. And the most effective solution for them seem to be creating a layer between the client and the server, when very specific client code is going to be located. And in there, they were doing some sort of processing in order to satisfy the needs of the client, the type of client that they had to respond to. So this way, the server takes care of gathering the data, while this adapter layer that we have in between the server and the client shapes the data in a very specific way for the corresponding client. Also, the same thing happened for the SoundCloud team, kind of the same story. They are migrating, in their case, they are migrating from a monolithic architecture to a more service-oriented one. So they encountered, again, issues with related to the APIs that they were using, and specifically when they were thinking about adding new features, but also working with different platforms. So the solution they found will again sound similar. It's the same approach as in Netflix. They decided that each use case would get its own API server, and this is the way that the developer had the freedom to actually optimize specific cases without needing to worry about other cases for other client types. And this is how we went down to backend for frontends pattern. It's easy to, at first sight, to think about best friends forever. And yeah, it might be as a way to improve the friendship between the client and the server. But taking it very specific, the goal of this pattern is to decouple the front end from the backend in the context of the architecture. So the BFF is all about building a layer that meets the exact needs of a specific client, as we've just discussed. One of the advantages of this pattern is the reusability of the code, because all the clients have the possibility to fetch data from a BFF server, creating a cache, making the process less complex and the client less chatty, which is something that we already discussed as being an issue. So yeah, we can take a very specific case in order to build our point. The issue about this approach, this traditional front-end and back-end separation, it's in the number of requests that we are doing, and that since the services are creating in a very generic way in order to be as to satisfy as many needs as possible, might give bloated results with data that we don't really need. Or so we have either too much data on front end and doing some workarounds on the UI in order to manage that. This kind of workarounds usually create a lot of issues. Or on the other side, in order to actually have a smaller number of requests and give a proper payload, so take the best of both worlds, well, that means that the backend will have to do some very specific UI-related logic processing. And using one way or another, we just end up when just deciding in which camp we just throw the fireball, because someone at some point is going to have a reaction about this. So if it is to just use a simple sentence to talk about the BFF, what is it doing is providing only data that the client needs, nothing more, nothing less. It helps us in having a smaller response type, helps us in terms of resiliency when it comes to our application, especially since we are treating use cases for types of devices separately, and we also can use it to create a caching, especially in cases of failures, because there are some data which, yeah, we don't need to sync at, I don't know, a specific time, every second or a minute. So we might want to take that to the cache, and in this way we reduce the chattiness. If you take it from scratch and talk about microservices, as API Gateway and BFF are two patterns to serve microservices architecture, we can simply conclude that both have the same scope, and that is the creation of a very reliable solution that makes our architecture more efficient and, in the same time, less expensive. So considering the setup that we've just seen before, even though easy to set up and efficient on small apps, this causes a lot of challenges when growing in terms of size and complexity when it comes to performance, security, scalability. So both API Gateway and BFF take the business capability to the next level, that's for sure. But we have to be very careful related to how we actually go in terms of specific needs of clients and the application, but also the context that we build around our architecture. So let's just look a bit at the API gateway approach. So we talked about the fact that, okay, it's creating a way for us to actually, as it does the BFF pattern is helping us in the maybe going slower with the chattiness. But as we can see, API gateway does not distinguish between client types. So basically, even though we are using it and maybe we have some adapter in between, even though it's helping us in the cross-cutting concerns and some generic operations that we want to do, yeah, we have a single point of entry into for all the clients. I've been working with an approach like this, so I have to just give my perspective that it's a very, having a single point of failure for your clients is not that fun. Also, if the API gateway is done, the project is done also, so it's not very reliable, let's say, if it's not built or it's not used the type of API gateway that yeah, can help the application and not just put some embed. So we were talking about the fact that the API gateway does not give, let's say, an approach for different types of clients. The BFF, on the other side, it is responsible for a single type of client. So let's assume that your system has a single page application and also for the web, and also a mobile approach client for a client for the mobile. In this case, each client would get its own, so to say, API gateway, which would trade off to a BFF. So each is being managed differently. So just to have an image about how this would look. The biggest difference in front end, in backend for front ends architecture and the traditional backend architecture is that the client no longer calls the generic backend. We are done with that. This way, each client will have its own BFF specific service. And that's how we are actually doing some processing at the BFF level for the UI logic. And this results in fewer mutual calls between the different services. So yeah, as we can see also in the image, each client is being satisfied on its specific requirements. So I don't have to worry about what the web is getting, or the web shouldn't worry about or shouldn't influence what the mobile is getting. And if we are talking about the mobile part, even more, things become more sensitive because, yeah, using the same payload that we are using for web, also for mobile, yeah, it will bring a lot of issues in terms of performance, and it's most of the time a trade-off in latency, especially since we can control the power of the network our application is going to be used on. So again, we go back to the BFF pattern as a way to actually satisfy the needs of each client. I'm going to just stop for a second on an approach and discuss a bit a question that I've received. What is the difference if you call those APIs from the client directly or from the BFF? Because yeah, you are calling them anyway. So where is the catch? Well, yes, but server-to-server calls are so much more lower in latency and high bandwidth, and this gives us a huge improvement in performance compared to direct calls to the server made directly from the browser. And yeah, if we add also the fact that we can control the payload, yeah, we can do some processing in the BFF layer. The differences are significant. So we've talked about the API gateway, we talked about the BFF. how do I make the right decision? Because they seem similar, yeah, they have some differences, but let's say that I'm just starting to work with my project and I'm trying to do some maybe move my project from one approach to another. And how do I know that I'm making the right choice? Well, you have to put yourself some question. First would be, how different are the needs of each client? This in the case that you are using different clients. If you are using different clients and they have very specific needs, yeah, maybe the best way to do this is by using a BFF. If not, and you have only a single client and it's not the flows are not that complex, you can go also with an API gateway approach. Then also a very good question is if the clients, if you have different clients, if they are owned by different teams. And also as a personal opinion, also it's very important when you have different teams that build different sets of services. Because in there can also, let's say you have only one client, okay, so only one UI, but you have different teams that build the services. In there might also be a problem when using the API gateway, because when you have a team that builds the backend, you have a team that builds the front end, it's so much easier to actually translate the data and take it from an API gateway and give a very specific payload and talk in terms of performance and agree on, than it is when a single client it's consuming a lot of services from different teams. So this is an organization matter. So in this case specifically, I would also use a BFF pattern, especially because I've been in this situation. Then another question maybe, since we are talking about data and the shape of the data, it's okay, if you are thinking about using an API gateway approach, is it giving you the possibility to do some aggregation? It's the API gateway that you are using providing that, or you have to also build the API gateway. You want to create something custom that might take into consideration also that. Because yeah, as we discussed, the shape of the data is very important. Then we have to think about cross-cutting concerns about the way that we are doing the authentication. Then how similar is the way that we are going to handle all these types of clients? So a very good place to start with is actually research and understand the capabilities of both, and then translate those capabilities to your project and see where exactly it's the best fit. Of course, we are talking about a lot of advantages, but we also have to be careful about the things that might get wrong, because as everything that brings us some gain, also we might have some costs. And if not costs, this might happen because of the fact that we are not using the tool in the way that is supposed to. Is like I'm using a tool in some work that it's not related to what that tool is actually supposed to do in order to improve the work. So yeah, we have to be very careful when it comes to duplication, because there exists the possibility that each BFF might implement similar capabilities. So I might end up with some duplicated code and some time that I'm wasting when it comes to the cost of development, when it comes to time and other resources. But this does not mean that this cannot be fixed. We can just discuss more between the teams. We were talking about different teams. And when we identify this type of duplication, we can consider the opportunity of creating some shared libraries that get certain functionalities developed only once and used in several places. Also, yeah, since we have more components, yeah, adding a new layer, we also have more, or we might have to work with more deployable units. So we have to be very careful about this, especially we have to I have a DevOps team that actually is doing monitoring, and it's automating very nicely everything when it comes to deploying and the deploy flow and everything that has to do with the context of actually managing those components and making them work together, let's say. So with some ownership and careful and quality of releases, we can save also this situation. Going forward, we are going to talk about GraphQL, maybe adding it to the picture in order to create a bit of context. I'm not going to go very much into details related to GraphQL as in very specific operations. We are going to talk about it in an architectural level, but I'm still going to give a bit of context for maybe for the ones that are not familiar with it. So from what we've discussed until now, each BFF can help us in situation where we have to handle one specific case or similar specific cases. And this fact allows us to create the API that gives us the freedom to manage them in a way that avoids the situation of one size fits all. That's something that we agreed on, I hope. So yeah, while this approach is giving us a lot of modularity, we need to be aware that there are still some points that need special attention, specifically in the idea that the contract between the client and the server side is fixed. So in order to loosen up this interaction and dependencies, a very clean way to do this and also serve different clients is by using also GraphQL or adding also GraphQL. So I was talking about the GraphQL as context. It started at Facebook because they were thinking about a way to reorganize the way they worked with APIs. They saw that there were some differences between the data that they wanted to use and the queries that they were doing in the server, and also saw that there is a lot of complexity and a lot of code that it has to be added to server and also in the client in order to actually have a decent response. So basically, the frustration is again very similar to what we've discussed with Netflix and SoundCloud. So long story short, GraphQL helped providing a more declarative way for the UIs to actually interact with specific data that they need. And that data is shaped by some resolvers. So it is very easy for us to specify what the needs of the UI are in the context of GraphQL. The cool thing about GraphQL is that it's actually being defined basically by two very specific terms, the query language on one side and the schema language on the other side. The query language, it allows us to fetch just the data that you need in a very efficient way and also very friendly. It is very easy to work with. And coming to complete the context is also the schema language, where we can define how and what queries we want to use or what mutations we want to access. So basically, going high level, let's say with GraphQL, we use queries to get exactly the data that we need in simple, in very simple requests. So basically, we talk again about very specific data for the client. And we can have a discussion about GraphQL without popping some questions related to how is REST bad and why can't we just use REST and things like this. So I'm just going to go through the differences very quickly. It's not a debate. First of all, it's not a debate between which one is better, but it's more like about having enough context to actually select the right tool for a specific job. So GraphQL gives a very specific with the help of the queries, we create a very specific request and get a very specific response. In the REST approach is not that simple because we have to create endpoints for each. And since we are going about endpoints, they are gone in GraphQL. Resources are declaring their own. REST works with different endpoints for each operations. As we just mentioned, GraphQL only needs a single endpoint, and the result is always very specific, related to or as a result to what we've just discussed. Then we have less HTTP calls, because while REST requires multiple calls for nested complex data, GraphQL calls only once. And the problem with the network payload overhead, it's not, it's improved. I wouldn't say that it's gone, but the issue somehow gets less significant if we're using, of course, the GraphQL approach as it should. Then it goes to the error coding processing, because in REST we have very specific HTTP error codes. In GraphQL we have 200 everywhere, and we are just wrapping the error information, so very specific error information. And the versioning, the issues with the versioning from REST are not encountered in the GraphQL approach, since GraphQL is implemented through the schema extension. So no more issues, or no more same issues on the versioning. So a little bit of looking just from above and seeing how they look. So specific requests, several requests, just a query, and it's giving the result. Of course, I don't want to go into the direction where I say, okay, GraphQL is perfect and the rest is not. There are cases and cases. We have to look very good on, again, on the project that we are trying to build. We might not need GraphQL to use. REST has a very long history, so it worked very good for a very complex application. It's still working in a lot of applications that we are using maybe on a daily basis, so it's not about which one is better. Not at all. An important drawback, though, is that, and maybe this goes especially when we have distributed teams and when we don't have that communication very, very well established, because REST APIs don't have a schema describing what the data structures are and what we are actually returning and what the endpoint is going to give us. We just have the endpoint and how it looks. And if I see something with participants, let's say, I might think that, okay, maybe the data that it's going to retrieve with some data about participants as maybe age or name and things like this, but I'm limited by the information. GraphQL, on the other side, comes with a very explicit contract, let's say, defining and displaying clearly the shape of the data that we can request and exactly what the response would look like and all the operations that we have available. And if you want to look more into this, it's called introspection. And it's something, at least when you're working in distributed teams, very, very useful. So we come to one discussion, since we've talked about how we can use and how is improving our work BFF and how is GraphQL improving. Well, could we just use them together in order to, or we have to just use them separately because they kind of do the same thing? Well, how about I have a complex system with a lot of REST services in place, and services are used by several clients, and I don't have the time to change them all. And at the same time, I really want to optimize the data that I'm retrieving. This case, I can use, let's say, if I have the services in REST, and maybe I'm building some new services, and I really, really want to go with GraphQL from that moment, and I can just combine them in order to get the best of both worlds. This is a very valid option. And even though in here I added, as a single point of, as a single middle layer, we can just make them different and create different schemas and work with data specifically for each client. So basically the client dictates the way the response should look like. We do queries on the server as precisely as we need. The server resolves the query that we've just created and returns the requested data to the client. So yeah, we can do that aggregation in the middle layer by using GraphQL. Of course, it has a lot of, as we were saying, it's friendly, it's performant, specifically for front-end developers, it's helpful a lot because we can have a better perspective on what is being built on the backend. But that's not really exactly what the point that I wanted to do today about GraphQL, because I think that GraphQL really shines when it comes to having more freedom when it comes to the data that we are using on the client, and the client has the freedom to actually request that data. The possibility to serve several clients, which entangles very nicely with the BFF approach. Also, clients can coexist on the same time, is no need or no problem into just doing again that approach where we respond to the needs of different clients. As something more to add on, we have less deployment complexity, less independence between separate teams, because as we were discussing, you don't really need the teams to discuss. They can see that introspection, that contract that they have, and they can work and see exactly what they have already available or not, and if it's working as it should. And also the UI is isolated from the changes, as in if something changes in the services or in the back, it's not really the problem of the UI, as long as it gets the data that it needs and the operations are not changed significantly. So yeah, if they want to do a refactoring or something like this, it is possible to do it without interfering with the client. So in the end comes the question, okay, since it's easy for, when we're using GraphQL, it's easy to have different clients. It aggregates the data so nicely with the queries. Do we need really to actually use a backend for frontend? And a discussion for, or a concern that it existed at some point is that GraphQL couldn't replace the BFF completely, because, well, yeah, we need to actually respond to different types of clients, and yeah, it might become for the schema that we are using, might become a bit overloaded and hard to work with, since you are trying to satisfy so many needs in just one schema. But this somehow it was worked out, if we can say like this, or it's a very good approach to actually go with this concern, is the solution that we received when the matter of partial came onto the market, as in breaking up the schema into separate npm modules. So developers can pick and choose different modules to use with their app, and the partials will dynamically be merged in a single in the single schema. So at this point, it's a matter of preferences and architectural details. Whatsoever, every good tool used in the wrong way or in the wrong context can give complication and issues. So yeah, we have to be very careful about how we do the choice. Last but not least, even though we have very good tools, we have to pay attention to some some ways that we do things. First, we have to be very careful, even though we are using GraphQL, how we fragment the data that we are using in order to actually complement the tool and not do a lot of requests for the data. The second one is that the best approach is to not start with a UI in mind, especially when we are talking about the services that are satisfying the needs of different clients. So we have to be very careful in that area also. Well, because I've been in this situation for a long time, yeah, and working in distributed teams and working with a lot of services and having a lot of complexity, and maybe sometimes wondering if the architecture is the best approach, the architecture that we're using is the best. I came to some conclusion. First, I think it's very important to let go of the association between front-end and back-end as in client and server. If you want to implement a solution as is the backend for front-end pattern and get the best of it, you have to think of the backend as more of an extension of the front-end. So the limitation is no longer available or valid. Then I'm not saying that you should master the whole stack, but you should have a very strong overview over the application context. And I'm talking about understanding maybe how the calls are made to the server, what performance means in the server part, what exactly is happening at database level, how the front and the backend are actually integrating. So it's not only, okay, this is my area of expertise and this is your area, and I don't want to know anything about front end or backend, depending on which team I am. So we have to be more open and actually understand what the context of the application is, the ecosystem of the application that we are working on, but also the ecosystem of software development in general, to have an overview, because this would also help us when we are taking certain decisions to think twice and maybe be more, also have the right questions in order to receive answers that might help us to take the right decision. And of course, work on the communication to backend developers. And this is specifically for the front-end developers, because we can understand that both sides have a lot of pressure on them to actually fulfill some specifications. But at the end of the day, it's a whole that we are working on, the application. So yeah, maybe we can do some baby steps in order to understand each other's context of work, and maybe see how it can be improved, the communication, especially when you are working maybe in a project that has a lot of history. It's pretty hard to actually change. So yeah, you have to just take it step by step. So I hope that my words today made you be maybe just a little bit interested in and maybe some curious thoughts about digging more on the matter and maybe pay more attention to the subject. I want to leave you with a thought that I strongly believe in. There is no silver bullet or golden hammer. What works well on one project can be pretty damaging on another project, especially if we're using it mechanically and we are not doing some research. And I really liked this, I don't remember exactly who mentioned this, but he was saying, like, there is some inherent complexity in software development and no magic tool will remove it. So choose wisely, research, and go with the choice that gives you the smallest cost and the biggest win. Thank you. Okay. Let's see if we have some questions. No questions for now. Well, if at some point maybe you will have a question, you can find me on Twitter. You can find me on LinkedIn. Let's discuss about the matter and maybe some approaches that you've been using in your daily work. Thank you again.